Okay, this is lesson 6 assessment, explaining the movement of air in a hailstorm cloud. This assessment is going to evaluate the following two standards: MSESS 2.4, develop and or use a model to explain the cycling of water through Earth systems, and MSPS 1 through 3. Students can create a claim, support their claim utilizing evidence, such as multiple pieces of credible qualitative and quantitative data. If you remember, qualitative is description, quantitative is numbers, and construct a scientific explanation. So with this, first thing you do, yes, you want to record your email, then you're going to type in your first name, and then your last name, and pick what hour you are in. And then as we move forward, question number 1. This is an image of a cloud with data from Salem, Oregon during the summer around 4 p.m. A is the date and time. B is the data of the temperature at the ground and 4 feet above the ground for the day in Salem. Remember, we did that activity. C is the data collected from the weather balloon. And D is an image of a helium balloon. Remember the observational data we collected based on that video here. Part 1, will write a claim below that answers the question, what caused air to move up in the cloud? You will use the following sentence starter to begin your claim. Air moved up into the cloud because, and then you'll complete your sentence here. The next part is evidence. Which two pieces of evidence from the data supports your claim? Just state the observations, no inferences. So we're not interjecting the story. We just want to know the facts. And then you'll type in your evidence based on what is up here. Then reasoning number 1, you'll finish the sentence below to connect your evidence to your claim. When air is warmed up, is it higher kinetic energy, more movement, lower kinetic energy, less movement, or the same kinetic energy no matter what the temperature is? You will select one of those choices. Reasoning number 2, you will finish the sentence below to help connect your evidence to your claim. When air is warmed up, the particles in the air become less dense, less space between the particles and sink, become more dense, less space between the air particles and sink. Letter B, become less dense, more space between the particles and rise. Or C, have the same density no matter what the temperature is. You'll select one of those choices and move on. All right, next part here, evidence. You're going to select 2, look at 2 is kept bolded, pieces of evidence that prove the claim you chose in the previous question. Is it in box A, the time and date of the cloud was on July 11th at 4 p.m. B, in chart B, the air 4 feet above the ground is cooler than the air right at the surface. C, in the chart C, the air temperature at lower heights is warmer than the air temperature at higher heights. Image D, the helium balloon in class rose when we heated it up. And lastly, E, in the soap bottle lab, the bubble expanded and rose when the bottle was heated. So you'll select 2 pieces of those 5. Reasoning number 1, finish the sentence below to connect your evidence to your claim. Warm air that rises up will stop rising when A, keeps the same amount of heat energy and does not transfer any of it. B, takes in more energy, heat from cooler air around it. And C, transfers its heat to the cooler air around it. Select one and then move on to the next question. Reasoning 2, finish the sentence below to help connect your evidence to your claim. Warm air will stop rising when the air particles is A, become more dense, less space between particles and causes it to sink. B, becomes less dense, the more space between particles causing it to sink. Or C, have the same density no matter what the temperature is. Therefore, density doesn't cause air to stop rising. Select one of those 3 and then move on. Looks like I have to do it. All right, question number 2. Big tall clouds that produce hail rarely occur in January in the northern hemisphere. Use the radiation and land surface temperature data from NASA to support the following claim. Hailstorms occur more in the summer than in the winter in the northern hemisphere. Here's your data right here. We see it's net radiation data from January 2018 and July of 2018. Net radiation is the amount of energy from sunlight that is absorbed by the surface, as we can see here, January, July. And then also land surface temperature in January of 18 and July of 18, January and July. Your first thing is evidence. Which two pieces of evidence from the data above support the claim? Remember, the claim is hailstorms occur more in the summer than in the winter in the northern hemisphere. You'll select one of these four choices. Choice A is in January more radiation is absorbed in the northern hemisphere. B is in July more radiation is absorbed in the northern hemisphere. C, in July the land surface temperatures are cold in the northern hemisphere. And D, in July the land surface temperatures are warm in the northern hemisphere. You select one and hit submit. And there you are. Good luck, good scores. Remember, you can stop this video and rewind for every question. Please take your time and ask Mr. Stone or one of your other science teachers, Miss Matan or Miss Clay, for help if you need it. Thank you very much.